Hello, my name is Tommy and welcome back to my second installment of this Pandas tutorial. If you haven't watched the first video yet, please look in the video description and you'll find a link to it. This is the table of content. I'm going to go through filtering and sorting, equality, non-equality, and logical operators. I'm going to talk about split, apply, combine, which is what's called groupby in SQL, as well as pivots. I'm going to talk about plotting, time series. I'm going to show a little bit about modeling and machine learning, just how to use Pandas as a tool to prepare data for these libraries, such as scikit-learn. And finally, I'm going to give you some tips and tricks at the end. This tutorial is really just me going through this notebook. There is no reason for you not to do the same, so please go to this link, GitHub, TommyOD, Awesome Pandas, and you can download this notebook and follow it as I talk. Okay, first I'm going to execute these cells from the previous tutorial just to get the packages and import the same files as we're using. Filtering and sorting. We've already seen some basic filtering. I'm going to show you a little bit more. First, I'd like to talk about this syntax where you do data frame and then you give it a list of strings. Pandas is smart enough to realize that this means that you want to select on columns. So if I uncomment all of this quickly, we'll see that if I do something like this, it's going to filter on columns. I can create a mask like this one. Now I just say that if the index is divisible by 11, it returns true. If not, it returns false. So the mask looks like this. And by mask, I just mean a vector of booleans. And then I can take this data frame, I set the index to the movie title, like so, and then I can use this mask using the same notation as above, and now it will select on columns. So this will give me it will select on rows. So now it's going to give me the rows which are divisible by 11. And it's the row number, not the index of the rows, because the index is the movie title now. So that's why I set the index as the movie title. So essentially what it's going to do is give me every 11th row of this original data frame. So df can select on columns or select on rows, depending on what the input is. Here is one further example. If I create a mask like this, this is a series which consists of booleans. Again, it's every 11th. That's true. And there's an index as well. Now it will not select every 11th index, every 11th row. It will actually select the indices which are divisible by 11. So there's a difference between using this mask, which is just a vector of booleans, and using this mask, which is a series with an index as well as values that are booleans. And the difference is that this selects every 11th row, and this selects the items in the index that are divisible by 11. So please be a bit cautious about what you do. Usually Pandas is really smart and will figure out what you're trying to do. But if you run into issues, you should check what you're actually giving the data frame as an index. So let's look at what this looks like in practice. Here's how, for instance, you can find movies and TV shows from Norway. The mask is this thing. I'm just going to print it out. You see that it just gives you the number, the index, and true or false. So if there's a Norwegian movie, it should be true, and very few movies are Norwegian, of course. So delete this, and then I use this mask to select a subset of rows. Here's a more advanced example. I can use the AND operator. I want high IMDb scores. I want a country that's not the US, and I want high grossing movies, for instance. And I want the top 3. So I create this mask, and I use the mask, and then I select the 3 largest. You have to notice 2 things. I'm using the AND operator here. I'm not using the word AND. This is element wise, and you have to do it like this. The second thing that you have to notice is that I explicitly use parentheses here, because the evaluation order of statements like these, you have to be explicit about your parentheses. There are really just a few ways of doing logic like this. There's element-wise and element-wise or, and you have the not operator, and equality and inequality. Okay. Let's look at group membership and string filtering. I can use this isIn method to figure out if the country column is in, if each row is in this this list or not. So that's going to give me true or false, and then I can use this. So these are the top 5 movies from Japan or Hong Kong, top 5. You can negate this using the tilde. So these are movies and TV shows that are not from Scandinavia. I can use the string accessor to, for instance, find the word Lord. So first I convert the movie title to lowercase, and then I search for the word Lord. And then I can use this mask and in addition ask for rows where the gross is higher than the bottom 25%, and that gives me this. So I get Lord of the Rings and Lord of War and stuff like that. Let's talk about split, apply, combine, and pivots. If you've ever used SQL, the split, apply, combine pattern is just like the SQL's groupby operator. So this statement, this Pandas statement, and the SQL statement is really the same thing, just in 2 different languages. And let's look at what it does. I select top 3 country, and then I compute for each country the average IMDb score, and I rename it. And then I select that from the data frame, and I do it in groups by country. And this is the equivalent syntax in Pandas. I want to specify that I could have passed a string containing country here as well. I don't have to do df.country. I could have passed a string just called country. And here's a nice visualization of what the split, apply, combine pattern is. You split your data into chunks depending on some value. Here it's depending on the airport. So if the origin is airport 1, it goes into this chunk. Airport 2 goes here, and airport 3 goes here. And then you have this apply, where you apply some function. Here it's the average value. So each of these chunks of data, you apply the average value, and then you combine it into a data frame or into a table in the SQL case, which is returned to the user. Here's an example. I see now that I ran this, and I would like to reset it. Sorry, I'm just going to quickly restart and clear output and run it again, because I don't want to see the output before I run the cells. So I restart, and then I'm just going to run the cells. I use Shift Enter to run the cells. Going down to where we're talking about split, apply, combine. Okay, sorry about that. So let's look at the data. We have countries and we have IMDb scores. If we just filter out these 2 columns, and we can run this to compute the mean IMDb score per country. And actually, sorry, it computes the mean IMDb score and the gross. And if I want to get the IMDb score, I can do something like this. There we go. There's an alternative syntax that I was talking about too, which is this. Should return the exact same thing. Yeah. So if I just do mean, it will just do mean value over every numerical column. And then I can pick out whatever I want. If I don't want to compute a mean over every column, and I know that I just want the IMDb score, I can do this filtering first. I could do something like this, and then now it will just compute the mean over that one column, which is one numerical column, which is IMDb score. Okay, let's use this for something. Let's find the directors with the most movies. So I'll just run this first. This is the output. A nice way to look at what's going on here is just to uncomment everything. So I'll do this. I take my data frame and I group by the director name, and that just returns a group by object. And the computation is actually done when I call the unique, which is the number of unique. So per director name, I want the number of unique over every other column, like this. So now it's for Adam McKay here, it's the number of unique director names, gross values, movie titles, and so forth. And you see he only has 2 unique content ratings, but he has 6 unique movie titles. And then I retrieve the movie title column of this data frame. Then I compute the top 5 largest, and I convert it to a data frame. That's just so the printing will look a little bit prettier, like so. So Steven Spielberg comes out on top here with 25 unique movie titles. These are I'm not sure if this is everything, but these are some of the built-in aggregation functions that you can call on group by object. So you can do group by mean, group by sum, group by count, and so forth. Let's make it a bit more interesting by introducing several groups and aggregations. We can group by several columns to do something like this. So for every country and content rating, I'm computing the mean IMDb score. Then I'm just rounding the values and converting to frame and getting the head. That's not very interesting. But I can use several groups or several columns as my groups. I can also use several aggregation functions. Now I group by director name, and I aggregate using the mean, the minimum, and the maximum. And then I retrieve the IMDb score. So these are perhaps not as interesting as some of the other ones. Everything looks pretty much the same. Adam McKay, he made several movies. His minimum score on IMDb is 6.3, his maximum is 7.8, and his mean is approximately 6.9. You can also define your own function. I can compute a spread as the maximum minus the minimum. I can do group by director name and compute the mean, spread, and number of unique, for instance. And here I just filter out the rows having number of unique greater than 1. This is something I didn't talk about earlier. You can pass a function into this location accessor. So it's a function of the data frame, and you can apply logic there. And that's really nice if you would like to do this sometimes if you're doing method chaining, because now this data frame is whatever this object is. That's pretty useful. So you can define your own function. And the mean and number of unique, Pandas knows about. It doesn't know about the spread. If I do this, it won't know what to do with it. Let's look at the error message. Series group by object has no attribute spread, so it doesn't know about the spread function. I have to actually pass a function. But if it's something that's known to it, you can just pass the string. I could also here pass like numpy mean, That would work. I could pass pandas series mean, and that would also work. So I think it just calls this pandas series mean under the hood when you do this. I can do several columns and several aggregation functions. So for instance here, I group by country and content rating, and I aggregate using this logic. So IMDb score is aggregated using the mean and the standard deviation, while the gross column is aggregated using mean and max. Looks like this. You see some nada numbers, some missing values here, probably because the standard deviation was not defined in this case. Maybe there's just one value or something. So you can do combinations of columns, you can do several functions, and you can do different functions on different columns when you aggregate them. So you have a lot of flexibility. Of course, you can do all of this in SQL as well, but I think it's nice to work with Pandas because the syntax is more concise. In SQL, you sometimes have to end up typing a bit more. Maybe that's just me, maybe I'm a bit inefficient in the way that I use SQL, but I prefer using Pandas. Stacking and unstacking. Let's look at a new data set. This is population in the world. So here, for instance, in Afghanistan, we have the population, the number of people, from 1960 all the way to 2015. And notice the strange format of this data. You have one country per row and one column per year. This is not good. This is not the way that you want to store data. You want to store it so that each row is an observation and each column is an attribute of that observation. That's not the case here. There's this nice paper by Wickham called Tidy Data, which talks about this. It's not a new idea. It's something that people who work with databases know, but he summarizes it really nicely here, and his mantra is that each variable you observe should be in one column. And that's not true because the population is in many columns. Each different observation of that variable should be in a different row. That's also not true because this is not one observation, this is many observations in this row. There should be one table for each kind of variable. That's true here. This is just one type of variable in one. Actually, it's actually it doesn't really comply with that either, because if you add a new country, then maybe you'd want to have a countries table. Oh, let's talk about how your data is structured, and we might be getting into too many details. Anyway, this is not good for our setting. This is not good for the kind of analysis that we want to do. We can put it in tidy format like this. This is much better. Now we have one observation is a row, which corresponds to a country, a year, and then the actual observed variable, which is the population. So this would you would think of country and year as being the index kind of, and then population is your actual observation here. And when you add new information, you just add more rows. You don't have to add any more columns like you would have to do it here. So when you analyze data, you want it to be tidy like this. Let's look at how we used stack to accomplish this. Here's the data. I first set the index to data source, so the country is in the index. Then I use stack 0, and stack moves I think of stack as moving the columns down to the rows. So here's what stacking the 0th column does. You can have multiple columns. You can have a hierarchical column structure. So I stack the 0th one, and it looks like this. Then I rename it to population. Now it's called data source. Oh, I didn't actually change this. I just gave it the name down here, population. Then I convert it to a frame, looks like this. Now we're getting really close, but I would like to just take these out of the index just to show you what you're probably more used to, which is just having the data as in columns instead of having this multi-level index, although that's really nice in some cases to have too. So I reset the index like so, and I just rename some of the columns, and I convert the year to a datetime format, so it's not an integer. So stack moves data from columns down to rows. It's very useful in this case. I talked a little bit about this tidy format and how you would want to store data in this way. If you have a database and you have several tables, you should read about the Boyce Code normal form, which is about how to structure data over several tables in a database and making sure that you have some tidiness in your data. It's really useful to know about in some cases. We have a problem with plotting libraries which might not want data in a tidy format. They might want it like this. If we want to track the population of Norway and Sweden, we would pass something like this to a plotting library. And to do that, we use the inverse of stacking, which is unstacking. So I set the index to this, country and year, and then I unstack. And unstacking moves from, it does the opposite of stacking. Unstacking moves up from rows to columns, while stacking moves from columns to rows. So I unstack the first level, that's this level. If I unstack the second level, corresponding to the first index, I would get this, which is not what I want. I want to move the first one up. So I get this, and then I filter. This is a multi-index column. Slice none, it says whatever is in the first one, that's just population. And then on the second level, which is this level, I want these two countries, Norway and Sweden. Then I get this. And that's exactly what you could pass to a lot of plotting functions. Pivoting and melting. These are more versatile versions of stack and unstack, you could say. Here's the data set. We can pivot this like so. So going from this to this, I tell the pivot method that I would like the index to be the year, I would like the columns to be the countries, and I would like the values to be the population, and it moves it up. And it's something that we could have accomplished using unstack as well, but pivot is more powerful. It can do more than just stacking and unstacking, while some things can be accomplished by both. Okay, let's drop countries where there are missing values. And what I want to do now is I want to compute a relative change since 1960. So I take this first row and then I divide the entire data frame, this thing, divided by the first row. And then it's going to broadcast, so it will divide this by the first row. It will just be 1. You'll see it here. And it will divide the second row by the first row and the third row by the first row, and so forth. This is called broadcasting in NumPy. And this is the result. So now I have the relative change. And if I want to go back, I can use melt. Melt is the inverse of pivot. And then I have tidy data again, and I have the population in relative growth since 1960. And I can use this to, for instance, make a plot like this. This shows the population growth of the 5 countries with the largest relative change. We see that the United Arab Emirates is on top of this, this metric. So to summarize, we have 2 powerful methods and their inverses for converting data to tidy formats and to formats which are not tidy, which is sometimes useful if you're passing to a plotting function, as we saw. And if you're computing things like this relative change, it's sometimes easier to do that when you have structured your data so that it's not tidy. There's unstack, which moves information up from rows to columns. And there's stack, which is the inverse operation. There's pivot, which moves from a tidy format and generally kind of move things up as well. There's melt, which is the inverse of pivot. And you can play around with these. It's not always easy to figure out immediately how to use them, especially pivot and melt, but they're very powerful and you can do a lot of stuff, which is helpful in these situations. Merging in Pandas is what's called joining in SQL, and it's the exact same idea. You have data coming from different sources. In Pandas, that's different data frames. In SQL, that's different tables, and you would like to merge or join information together. So here's an example. What I want to do now is I want to, in my data set, I want to make a new column showing every director's number of movies. No, sorry, not number of movies. I want to show the mean IMDb score for every director. So I compute the means of the directors by groupby, mean, and then I choose the IMDb column, IMDb score column, like this. And then I can merge this data I merge my director means data frame into my original data frame like this. And it's a left merge. This means that in my left data set, I keep everything. And if I have information corresponding to the right data set, then that's great, but I'm going to keep every index here. So if I have 100 people here and I only find information in this table or data set about 20 of them, then there will be maybe 80 missing values corresponding to that. But I still keep everything. But if I did an inner join, I would only get information about those 20 which are in both data sets. So that's the distinction. I do a left join now because I want to keep all the information in my original data frame, and I want to merge in these means if I find them. And I need a key to join on, to match on. And my left key corresponding to data frame, that's the director name column. So this is director name. And on my right data set, which is director means, I use the index, which is this. So merging these together, you see that I have this new column called director IMDb score. And so, for instance, James Cameron, his IMDb score, average IMDb score over all his movies is 7.9. So maybe he just made that one movie, while some here have different information for that single movie and for the director. Here is another example. I get all the directors of movies made in the US, and for these I do a group by director name and I compute the mean. So that's directors movies that are in the US, and I compute the mean, and I do the same thing for Canada. So now I have some directors who have made movies in the US, some have made in Canada, and some have made both types of movies. And here I do another join, or merge as it's called in Pandas. This is an inner join, so now I get information about the directors that have made movies in both the US and Canada, and I compare the mean IMDb score for those movies. If I change this to left, just to show you, I get a lot of missing values. These are all directors who have made movies in the US but not in Canada. If I do a right join, the opposite happens. Here's a director that has made movies in both Canada and the US, and this director, Andrew Curry, he's made only movies in Canada and none in the US. So I only get this piece of data, and this one is missing. But if I do outer, I get both. So I will get every director, and it's possible that they have made movies that are either in the US or in Canada or both. If I do inner, I only get the directors that have done both types of movies. You can play around with this. There is a great thread on Stack Overflow, Pandas Merging 101, which you can check out if you want to read more about merging, not merging. Let's talk about plotting. There are two ways to do plots in Pandas. One is to use the built-in plot methods. There are about 10, slightly more than 10, that are built in. Here's an example. We take the country column and we do value counts. We get the top 10, do some sorting, convert to frame, and here's the crucial part. We call plot on this data frame. Let me show you the data frame. That's not printed, like so. If I do a semicolon in these Jupyter notebooks, the output or the statement is not printed. But if I remove it, it's printed. So I have this data frame which I want to visualize, calling plot bar h. Creates this for me. If I just call bar, it will create this. So that's quick and easy, and it produces a plot that's, I mean, it's reasonably good, and it's really nice if you have a new data set and you'd like to inspect it and just look at things quickly. But if you want more control over what your plot looks like, there's the option of going through matplotlib, which I'll show you, but first a little bit more about the plotting capabilities of Pandas. There are inputs like these into the plot function, which you can call. I can turn on a grid, I can change the color, change the font size, give it a title, change the figure size if I want to. And this helps somewhat. I still don't think this plot is it's not perfect. It's not exactly how I would want it to look in a publication, say, but it's fairly good. Here's a final example doing a line plot. If I just call plot and I don't do plot dot bar h or dot bar or anything like that, it assumes that I want a line plot. So you can play around with this. You can get help for this plot by doing, for instance, help pandas data frame plot. Yeah, and you see you have quite a few options. The second option is going through matplotlib. This gives you more control, and you can really make some high quality plots if you do this. And what you do is you create a figure and an axis using matplotlib. I'm not going to talk a lot about matplotlib since it's not really the scope of this tutorial. But I create this new series here, and then I call the plot method, and it has a keyword argument called x for axis, and I send this axis in, and it returns the axis, adding these lines. So then I take the returned axis object and then I tweak it by, for instance, setting limits, setting labels, and so forth. And then I get something that I think is better compared to the defaults. It looks a bit better. If I want to save this, I can just call this. And then going to my tutorial folder, I see this figure now, and it's a beautiful PDF, and it's vectorized. You can zoom all the way in, and it looks really good. F11, and then I'll just uncomment this again. Here's another example of plotting, and I'm doing this kind of to show off my library KDEPy for kernel density estimators. I want to use .values instead of .numpy because I'm using Pandas 0.23, and 2numpy is introduced in the next version, which I'm not using right now, but you should probably use 2numpy if you have that version of Pandas. But I'm just going to change this quickly. And here's the graph showing IMDb scores, and IMDb scores weighted by the gross of the movie. And the reason why I wanted to show this is because you can't expect that people who make libraries necessarily take Pandas data frames as inputs. So then you have to convert it to typically a NumPy array or maybe a Python object. And the way to do it is to use .values. So here I take data, IMDb score, and then I pass these values to my KDE fit method. And the same thing I do here, and then the weights are the gross values. So if you're interfacing with other libraries, you can't necessarily send in a series or data frame. I will get an error, must be of shape ops dims, because if I call shape, then it gets confused because it expects the input to be an array. So you should be aware of that if you're using Pandas to pipe data into other libraries. There is more to say about plotting. There's this matplotlib gallery. There's this other package called Seaborn, which produces some beautiful graphics. And there's a nice YouTube video talking about the Python visualization landscape. So here you can see for matplotlib just the amount of figures that are accessible. And if you click on any of these, you get the code generating the figure. So that's really useful. Here is Seaborn. It's beautiful. You can create all kinds of cool visualizations. It's really high level. So you can look at that if you're interested in visualization. Time series. Let's look at some data from Google Trends showing Python, Pandas, SAS Enterprise Guide, and Microsoft Excel. There's a problem with this dataset, and it's these values, because instead of encoding them as 0, they're encoded as less than 1. So Pandas will believe that this column in particular is a string because of this less than symbol. So what I'm doing here, and you can inspect this at your own pace, what I'm doing is I'm replacing this with 0. And then I'm doing some other transformations, such as changing the name of the columns and setting the index to the date. And then we have this data. And you can visualize it using the plot function. And it will then draw 3 of these. If I wanted to add a grid, for instance, I could either do grid equals true, true, or I could go x grid true down here and remove this, and it should accomplish the same thing. Yeah, so I can either work in the plot method, or I can change the returned axis object afterwards. Let's look at the seasonal component of this. I can create a new column called week of year. Like so. I already talked about assign. I create a new column called week of year. I take the data frame as input to an anonymous function, and from the index I convert it to a series, and then I use this date time accessor, which lets me do date time method calls on this new object. And it has one called week, which returns the week of the year. So then I do a groupby, which you know all about. I compute the mean. I get something like this. So it's aggregated over all these years, and we should see these dips around Christmas. We should see those in both Python, and we should see them in Microsoft Excel. You see them quite clearly. They're the seasonal component. So if I plot this, you can see at the end of the year there's a dip. And that's the average over all of these dips here. You can do the exact same thing as above, but group by month instead of weeks. And then you use dt.month instead. And you can Google this dt date time accessor, and you can figure out what all of these are. You can do things like day of week. You can do the day of the year, the month. You can do, I think you can do the quarter, which quarter it is in the fiscal year, and so forth. So quite a lot of functionality. Rolling window functions, pretty neat. You can access them using this .rolling, and then what's window here? Window is just the size of the rolling window. If I take it down to like 4, I just smooth it out a little bit. If I take it up to 20, it smooths it even more. And if I go to 50, it's very smooth. So this is a window of size 50. It's a triangular window, and it's centered. And then I compute the mean. So it's just this, rolling mean over the time series. You could do something like rolling standard deviation. No, I can't. Is it this? Okay, I don't think that's possible. I'll show you how to do it later using rolling and then aggregate. I think it's like aggregate NP. Okay, I'll show you later. Okay, let's just take this down to 12 or something. Yeah. Here's the standard deviation. What did I do? I use aggregate. So I do rolling and then aggregate, and I do PD for Pandas series standard deviation. And then you get a rolling mean, which is this solid line, as well as a rolling standard deviation, which is this dotted line. So you can see there's more variation around Christmas, it seems. More local variation, because you have this dip every Christmas. You can resample time series. Here I show you how to upsample to daily frequency, because this original data is of weekly frequency, and how to downsample to monthly frequency. And when you sample, do resampling, you have to specify some function. So here it's padding the data, just repeating the same value, and here it's taking the mean within each month. So you can do these kinds of computations on time series. And there's more to say about time series, but to be honest, it's not something that I've used Pandas for a whole lot. But if you go to the official documentation, you can find out what other functionality exists. Now let's talk a little bit about machine learning. I'm going to show you how to create dummy variables, or one-of-k encoding, one-hot encoding, which is needed when you feed data into many machine learning algorithms. I'm also going to show you how to train a model going to train a really simple model just using linear regression, because it's not really the purpose of this tutorial to show you machine learning, just to show you how to use pandas. We can use this set option to just display a few more rows and columns. We then reload the data just to make sure we have a fresh copy, drop missing values, drop duplicates, and then the data looks like this. So what I want to do here is I want to dummy encode this content rating, because I can't send this into a machine learning algorithm. Then I'm going to show you how to dummy encode genres here, which is a bit more tricky because we're going to have to do some splitting on these. And then we're going to try to predict the gross value based on all these other columns. So based on everything else, we're going to see if we can predict the gross value. And getting dummy variables is really simple using this PD get dummies. So if I give it this content rating column, it produces this. And I'll do 5 here as well so we can compare these. So this first row, it has PG, so you get a 1 for PG here and 0 for everything else. The second one has R, so you get a 1 for R and so forth. So when we give this to a machine learning algorithm, it's going to choose a coefficient for each of these, because we give it we're going to feed it to a linear regression model. So it's just going to be a linear combination of columns, and then if you get a 1 here, it's going to learn a coefficient for this column. And then we take these dummy variables and we use the merge, which we talked about, and we left merge it into our original data set. Then we drop the original column so it looks like this. So now we're getting close to something, but before we can give this to an algorithm, we also have to dummy encode these values. They're a bit more tricky because the number of distinct values is a function of the row. So here you have 2 and here you have 4 and so forth. So first I am going to figure out how many genres there actually are. And to do that, I will go to the genres column. I will, for the string, I will use the string accessor and I will split it on this pipe or vertical line, and I will apply the set function, and that's going to give me this. It's going to give me a set for every single row. Then I'm going to do a union over all of these sets, and that's what I do here. So these are the available genres in this data set. Then I loop over every genre here. I create a new column with the name of that genre, and I ask if the string, if the original column, if that string contains that specific genre, then this new column is set to 1. If not, it's set to 0. So then it looks like this. I got rid of the original column and I added all of these columns instead. And now you can have several, like this first movie, it's both a fantasy and an action movie. So you have interactions between these columns. Cool. Now we're ready to pass this to a machine learning algorithm. Let's try to predict the logarithm of the gross value. I'm going to take logarithms of the gross and the budget because they're so skewed. They're so there are some really high values, and the distribution looks very log normal to me. So I'm just going to take the logarithm. Then I'm going to drop the original columns, and we have something that's a bit easier to work with since the outliers will not affect it as much, and it looks more normal distributed now. Here's how you can interface scikit-learn. You can actually just send in series and data frames into scikit-learn, and it will figure it out by itself. So here I make this super simple model because my inputs it's just a vector of ones. So linear regression will then just learn the mean value. So this is just if you take the mean of every log gross, then and you just predict that mean, then you would get a score like this. So the X that I feed into the machine learning algorithm is a NumPy array, while the Y is a Pandas series. So you can combine these. And in general, scikit-learn is a library that interfaces pretty well with Pandas. If I wanted to convert this, I would do dot values. It shouldn't matter. So as long as it gets something that it can work with, it doesn't really matter if it's NumPy or if it's Pandas series or Pandas data frame. This first model got a root mean squared error of 0.92. Let's keep that in mind and let's train a slightly more serious model. Now I drop the columns which don't matter for this algorithm, the movie title and what I'm trying to predict, the logarithm of the gross. Is it pronounced gross or gross? I'm not sure. I just realized I'm not sure how it's pronounced. I'm sorry if I've been pronouncing it wrong. Okay, I create this linear regression and then I do cross-validation 10 times. These are the columns that I now use. Most of them are just the result of this dummy encoding. And this is my new model. I just wrap these scores, which is a NumPy array, into a series, and then I use the box plot function just to visualize it quickly. And now the mean score dropped, so this model is better than this one by quite a bit, which is not surprising because this one doesn't really use much information. It just computes a mean, while here we have some freedom to look at the duration, the budget, and what type of movie it is to make a prediction. Finally, let's talk about a few miscellaneous tips and tricks. I'm going to talk about performance and then I'm going to talk about exporting. So you want to use the built-in methods instead of doing things your own way if there is a built-in method. For instance, if you want to get the top 50 of something, you want to use the built-in nlargest. Two alternatives is to do a maximum to get the top value 50 times in a row, and sorting and then getting the top 50. And we'll see now when we create a data frame or series with 1,000,000 entries that this one is going to be slow, this one is going to be slow, and this one is going to be fast. So the first one, computing the maximum 50 times, that takes about 1/4 of a second. Of course, that's so fast it doesn't really matter, but we only have 1,000,000 data points. This is a bit faster, sorting and then computing top 50, but it's still about 1/5 of a second, while this is very fast. It's 27 milliseconds, which is almost exactly 10 times faster than this. So the reason for this is there's a smart algorithm for finding the nlargest, which is, it's kind of like a mix of these two actually, which is optimal. And you should use the built-in methods if you can, especially if you have a lot of data. Here it doesn't really matter, but if you have 10 times or 100 times more data, it will matter more. You want to do filtering before you do computations if you can. This applies if you're getting data from a database, and it applies if you're doing computations in Pandas. Here I compute the mean over every column, but I'm really just interested in the IMDb score. So that's an expensive operation compared to this. It's like 1,000 times faster. Because here I first get the column that I want and then I compute the mean. Here I compute the mean over everything and then I get the column. So 1,000 times faster. You can use a sorted index and this can speed up filtering. So here I first sort by the gross value, and then I set the index. What am I doing here? I'm setting the index to the director name, and then I'm sorting it. And then I'm doing a query on the director name. Yeah, that's what I'm doing. So here, this is more slow than this, because here it has to go through every director name and check if it's equal to O. And here it will location. Let's see what this looks like. Director name. Let's see, sorted index, location, slice O, and then none. What does this look like? So I'm doing O. I don't remember precisely what I'm doing here. What's this slice? I'm sorry, I don't remember. I thought what I wanted to do was to look at like choosing director starting with O or something. Sorry, I'll add a comment explaining this if I figure it out. I'm not sure what I was trying to do. My point is that if you have a sorted index, some filtering operations and stuff like that can be faster. Okay, moving on. Sorry. If you can use a vectorized function, that's better than using Python built-ins. I already did this example with map versus apply, where map uses a Python function on every entry, while apply uses a vectorized numpy function over the underlying vector here, so that's faster. And of course, if you have more data, it's going to be even faster compared to this. It's going to matter a lot more, this speed difference of approximately, what is it, 7, 8. Here's another one. We want to compute mean of differences. There is a fast numpy solution. I first take a vectorized difference, and then I compute the mean over that vector, and that just takes 2 milliseconds. This pure Python solution is going to be a lot more slow. So the speed difference here is about 300 times faster. So that matters pretty quickly, actually. So you have to be aware of that. There's this great online book called From Python to NumPy, which talks about vectorization, and you should really have a look at that if you're interested in how this works and why it works and what kind of problems you can efficiently vectorize. Equality checks is also an example of something that you should vectorize. And again, it's really about using the built-ins. If I define this function isUSA, that's going to be slower than using this this vectorized check here. As you can see, it's 3 times faster, because this has to do a lot of function calls and stuff. You can export data, save it as a CSV file if you're sending it to a colleague, save it as an Excel file if you're sending it to a business person. You can generate LaTeX code, which you can copy into your research or into your documents. You can generate HTML. This just looks like printing it out usually does, but here you see the HTML. You can copy this and use it in a website. You can also write directly to databases using DataFrame to SQL. There are some resources which you can look at. There is this repository of Pandas exercises, and that's really good if you want to do some exercises now, because I haven't really included any exercises in this because this repository contains a lot of good exercises. You can go here and you can solve these exercises if you feel like you need practice. It's probably a really good idea. If you didn't like this video or you want to watch more videos, I've collected a lot of videos in my repository here. So you can click on any of these and you can go on YouTube and look at videos. There are a lot of good videos out there, and I'm sure this is not going to be the best of them, but I hope you enjoyed it anyway. Thank you for watching, and hope you learned something.